Okay, so if you take a sphere, the only measurement involved in creating a sphere, which is the set of all points, a fixed or a given distance from a fixed point, is that given distance, r, the radius. Okay, and so your surface area for a sphere is going to be 4 pi r squared. And your volume for a sphere is going to be 4/3 pi r cubed. Okay, the biggest mistakes that students make on these is exchanging or mixing up the powers. Okay, so again, keep in mind what surface area is measuring. Surface area is measuring how many dimensions? Area is two-dimensional, so the power should be a 2. Volume measures 3 dimensions, so its power should be a 3. Okay, so again, keep that in mind when you're looking over the sphere. And then there's variations from the sphere that you need to be aware of. And the main one is a hemisphere. And so if you take half of a sphere, you still only have a measure that's a radius. Okay, but in dealing with a hemisphere, its surface area is going to be composed of both the curved portion and the base. And so now realize with a hemisphere you create a base. So if you take a sphere and cut it in half, okay, not only do you have the area of the curved portion, but you have this flat circular surface also. So the curved portion is going to have a surface area of what? It's half of that of a sphere, right? So half of 4 pi r squared is going to be 2 pi r squared. But then you also have to add in this flat base. And what shape is that base? A circle, which is given by pi r squared. So what do you get as your total surface area for a hemisphere? 3 pi r squared. Okay. So again, be aware of that distinction. And then the volume for a hemisphere is just going to be the fraction of the volume of a sphere. So a hemisphere is half a sphere. That means its volume is going to be half of what it would have been for the whole sphere. So you get 1/2 of 4/3 pi r cubed. And if you wanted to simplify this, the 2 and the 4 reduce to a 2/3 pi r cubed. Okay, so you can think of that individually or just as a fraction of the whole sphere. All right, the last type of problem that you might see that's similar to this sphere is if you have a sphere with a whole slice taken out of it. Okay, now if you can't draw this, that's okay. You can give it your best shot. If you just draw a circle and then construct or draw 2 little arcs that meet at the same point, and kind of identify where your center would be, and then you can just draw lines from the center to each of these points, and then I'll use a curved arc to represent. Does everybody see kind of what that represents here? So it's like an orange with this, like a full slice removed from it. Does everybody see that? Okay. So the last thing that you might see as a variation off of this sphere is a sphere with a slice removed from it. Okay, and if that's the case, you're still going to be dealing with a radius. Okay, but now you're also going to have to identify that there's a portion missing, or if you look at the angle that remains, this m value, is if you look at kind of just a flat, a top view of this circle here, it's going to look like a circle with a sector removed from it, and where your m value is this whole rotation. So if that's the case, the way that you would identify the total surface area for this would be you take this the total volume of this is you take 4/3 pi r cubed, and you're going to multiply that by, what do you think you're going to get, or what do you think you're going to multiply by to see what remains here? a portion of a circle, m over 360. So it should be what you would expect. Now notice you can reduce this down if you wanted to. 360 and 4 can cancel, but I just leave it exactly as it is. So the total volume for this sphere with the slice removed is m over 360 times 4/3 pi r cubed. It's just a variation of the volume here.